Hello students, today we are going to see some more interesting and important questions from MS Chouhan sir's Organic Chemistry Level 2 Isomerism. Come on, let us discuss. As we are seeing questions from 11 to 20, the first question tells about match the columns only. So in the column 1 and column 2. So column 1, they have given Newman's projection. Column 2, we have to find the name of the compound. So usually in that circle, it is a back carbon. The line starts with the front carbon. So this is CH3, CH2. It is a front carbon. This point, it is a front carbon. And the circle, it is a back carbon. Okay, let me write that compound. So this is actually here CH3 CH2. So this is front carbon. This point, it is a front carbon, CH3 CH2, and here C and here H. So this point is CH2 CH3. So here CH2 CH3, and then the last one CH3. This point, it is CH3, right? So this is, I just mentioned here, this is front carbon and this is back carbon. So front carbon and back carbon. What is the name of this compound? So this is one. From here we can make out from where here 1 and this is 2 and this is 3 and this is 4 and this is 5. So 3-methyl pentane. So what is the name of this compound? This is 3-methyl pentane. So this only 3-methyl pentane as a compound name. So answer will be B only. I hope you got the clarity about how do we identify. So dot, it is a front carbon. Circle, it is a back carbon. Please remember. So dot means this point will be getting this point and this point. So this point, it is front carbon. Outside, it is back carbon. In that way only I just mentioned. Okay, hope you got the clarity. Come on, let's go to the next point. Here what it is, the same idea, CH3 CH2, it is a front carbon, and the same way here CH2 CH3 back carbon. Okay, let me write this equation, CH3 CH2, and then this CH, and here one more H, here CH3. So CH2, this is CH3 CH2, CH2 CH3, this is front carbon, this is front carbon. First one, it is front carbon. Second one, it is back carbon. The same way, this is front carbon and this is back carbon. Hope you got the clarity. So what is the name? CH3, CH2, CH2, CH3. N-butane. N-butane is the correct option. This is only directly they have given. So Q is the correct option. Okay, now this one. In this, here front carbon. This is front carbon and this is back carbon. So how do we write this point here? It is a back carbon. So the front carbon shows it is a cyclo compound. Easily we can make out. So cyclo compound means it is 1, 2, 3, 4. So this is 5 like. So back carbon which is going to attach. So this is pentane, cyclopentane like it shows. Okay, so cyclopentane like it shows means, so now it is a back carbon. So back carbon, I'll put it in different color. So this is hydrogen and this is hydrogen. You know, back carbon 2 hydrogen is available. You see here, this is 2 hydrogen, no? This one hydrogen and this one hydrogen. 2 hydrogens are there in back carbon. And front carbon CH3 and cyclo pentane which is attached with hydrogen. So methyl group which is attached with that here CH3. Here CH3, here hydrogen. So methyl cyclopentane only is the correct option. Directly it has given that option. Yes, I hope you got the clarity. See, white color it is back carbon and orange color it is front carbon. Hope you got the clarity. Dot, it is front carbon, circle, it is back carbon. And this next one here, 1, 2, 4 trimethyl cyclohexane. See, directly they have given that answer. Now let us check with that. Here actually cyclohexane. So that means here which is attached with that. So that means it looks like cyclo compound only. Okay, now let me draw the structural formula here so that it will be easy to understand. So this is chair conformation. So this is chair conformation like this. Okay, so this is chair conformation in the different color. I'll show that. So this is here, this is front carbon which is attached with front carbon, and back carbon here CH3 CH3, and here front carbon CH3. Yes, okay, let me write that structural formula clearly. Here hydrogen and here hydrogen. Okay, and the next one 1, 2, 4. No, so that means here what it is, where do we identify 1, 2, 4? Here 1, 1, 2. Okay, now let us start with here. Here CH3, here CH3, here hydrogen, and the same way here CH3, here CH3, and here hydrogen, right? Okay, 1, 2, 3, and here 4. This is 1 and this is 2 and this is 3 and this is 4. So in that fourth point it is hydrogen CH3. CH3. So in this, see here 1, 2, 4 trimethyl cyclohexane. So 1, 2, 3, 3 methyl. So 1, 2, 4. So this is 1, 2, 3, and 4. 1, 2, 4 trimethyl cyclohexane. See, so that means this is the way we can identify easily we can identify. So this is back carbon. You see back carbon. This is back carbon, and this is front carbon dot. It is this point. It is front carbon, and the outside part it is back carbon. Hope you got the clarity about all these questions. How do we identify Newman's projection formula into normal name of the compound? Generally, front carbon, back carbon. If you know, easily you can identify the structural. That means name of the compound. Very easily you can identify normal structural formula. Right? This is Newman's structural formula. This is normal structural formula. Come on, let us go to the next question. First column it is a molecule, second column it is a property. So this is generally they have given the compound, we have to identify what are the properties. So here in this compounds, here we have to identify whether it is optically active or optically inactive. Optically active means POS COS will be absent. Optically inactive means achiral, first point, and second point POS COS will be present. So in that way easily we can identify what it is, whether it is optically active or not. And one more point, if it is achiral, POS, COS will be present. It is actually what it is. It cannot rotate PPL. That means plane polarized light. So this point also it's observatory to identify. Yes, the first point. Actually, this is a cyclohexane chair confirmation, and in that bridge head also it is available. Come on, let me draw the structural formula. So cyclohexane, right? This is cyclohexane, and then another one more. It shows like bridge head compound, right? It shows like bridge head, like this. It is right. So that is what 1, 2, 3, 4. 1, 2, 3, 4, right? Okay, so this is actually POS is present and it is achiral. Achiral means what it is? Optically inactive. And the next one, what it is? POS is present means it cannot rotate PPL. PPL, plane polarized light. Okay, it cannot rotate PPL. Yes, this Q, it's correct. And even R also it is correct. Okay, so for that A, what are the things are possible? Here Q and R. So Q and R, what it is? Q cannot rotate PPL and plane of symmetry. So these are the two things are possible for uh, option A. Okay, so this point A. And then second one B. Now as we are cutting over here CL, here wedge CL and dash CL, and here BR. So naturally here POS is absent, COS is absent. So POS, COS absent means it can rotate PPL. So that means what it is? This is P, option P. So it can rotate PPL. That means it is actually what it is? Optically active. Optically active, chiral. So optically active. I hope you got the clarity. So here it can, those who are having chiral center can, it is possible, optically active, and POS CO is absent, right? Okay, now third one. So third one, what it is? So as we are observing benzene which is connected with diphenyl, we can say usually this is bromine, and this side AS methyl, this is bulky group. As you observe, this is a bulky group. And see, as it is observing here, one point it is wedge, and other point it will be dash usually, right? So one point it will be wedge, the other point it will be dash. So that means here also you can observe here one side this is BR and this side bulky group. So naturally here POS COS will be absent. POS absent, COS also absent, though it is diphenyl which is connected. But here bromine which is there, here bulky group 3 methyl group which is attached with AS arsenic, right? And this one point it is wedge, the other point it will be dash. So totally it is what it is. POS COS will be absent. POS COS absent means optically active. So optically active, it's a chiral. It can rotate PPL. So what it is? It can rotate. That means P. So P, option P, it is possible, right? And the last one, this is very simple. See, if you know that concept, easily we can go for that exercise 2 usually. First level 1, you will be learning the concepts. Second and third, it will be very easy because you are thorough in that concepts. No, so second exercise and third exercise, it will be very easy when you are learning the concepts thoroughly. Right now, third one, what it is? Actually, it is a non-planar compound. C double bond C. Here, wedge and dash. Here, what it is? Dash iodine and wedge Cl, and then same way CH3, CH3. So this is even cumulene. Even cumulene. Cumulene. See, allene also we can say, cumulene also we can say. So even cumulene, and this is non-planar, and so this one optically inactive, optically inactive. So actually this is what it is, achiral. See, achiral, right? CH3, achiral, right? So then what do we say? Here optically inactive compound has POS. POS is present but does not has COS. COS is absent. Why? Because here CH3, here Cl. So COS is absent but POS is there. Anyway, one it is there, right? So then optically inactive, and next one what it is? So here what? Center of symmetry absent, plane of symmetry it is available, achiral and optically inactive. Optically inactive means what it is? It cannot rotate PPL. So this is Q is the correct option, plane of symmetry, right? Q and R. Okay, this is for Q and R. I hope you got the clarity. How do we identify all these points? If you know the concept, you are able to identify the answer correctly. Yes, come on, let's go to the next question. molecule and stereo center. So that means the stereo centers means no need to identify stereomers. That means stereoisomers. Only we have to identify chiral carbon. How many chiral carbons are available? That's all. Right. Now here double bond it is there. So double bond is there means it is applicable for GI. That is geometrical isomers. Right. So in that, so this is one chiral center and this is one chiral center and this is one chiral center. So how many chiral centers are possible? So three chiral center. Here unsymmetrical 2 to the power of n. That means n equal to 3. So 2 into 2 to the power of 3. That is 8. You don't need to identify here. What they are asking only stereo centers. So what the question according to that you'll be answering. And the second one here, the triple bond, it is a triple bond, it is not eligible for geometrical isomers, only double bond. In that double bond, how many stereo centers are there? Here one stereo centers are there, here one, and here one, and here one. Yes. So chiral carbon, how many chiral carbon from this compound? So here 4 chiral carbons are available. So only they are asking about the chiral carbon, how many stereo center, chiral carbon, both are same only, right? Okay, now next one, how many chiral carbon is available in this point? So here, yes, double bond, oh, here actually lone pair of electrons are available. So this also one chiral carbon. You please remember. Of course, this is one chiral carbon, this is one chiral carbon, and yes. So this, do you think it is having a chiral carbon? No. See, CH3 and CH3 both are same. So it will not be a chiral carbon. Right now, how many chiral carbons? Only 3 chiral carbons. Yes, of course, you got it. And the last one here, pH it is there, CH, CLET, so that is ethyl. So only one chiral carbon it is available. So this point only. I hope you got the clarity. How many chiral center? That means chiral carbon and stereo center both are same only. How do we identify here? Symmetrical or unsymmetrical? We don't need to identify. They are asking only chiral center, that is chiral stereo center only. Hope you got the clarity. Come on, let's go to the next question. The next question, as we observe this compound column 1 and 2, this is a molecule and this is a stereoisomers. Like last question, stereo center, this is stereoisomers. So stereoisomers means how many stereoisomers are possible in this molecule, in this compound. Right. Now, as we observe here, we are seeing even cumulin 1 and 2. Even cumulin actually, that is even cumulin does not show GI. That is very important point to be noted. So I just mentioned even cumulin does not show what it is, GI, geometrical isomer. That is one important point to be noted down, right? Okay, now come to this point. So even cumulin does not show geometrical isomers. Okay, how many chiral centers are available? Yes, of course, here one chiral center, here one chiral center, and this point completely, the ring structure, it shows actually chiral. So ring, it is one chiral carbon, right? Plus ring, generally ring point, as well as here 2 chiral center, right? 2 chiral carbon. So altogether 3 points. So here this is symmetrical or unsymmetrical? It is completely unsymmetrical only. Unsymmetrical means what is the formula you will be bringing? Unsymmetrical. So unsymmetrical means 2 to the power of n. So 2 to the power of n equal to how much? 3. That is what? 2 chiral carbon and 1 ring structure. So this is 3. So n it is 3. So 2 to the power of 3. So that means 2 into 2 into 2. So altogether 8. So 8 is the point. So this is 8. 8 it is 1. So that means it is yes, right? So this is 8 isomers are possible and yes, right? Now the second one, again there is a even cumulin. So even cumulin does not show GI, and the ring 1 it is there, and the chiral carbon is only 1. So how many are available? Here 2 only. So this is unsymmetrical, same formula only. So directly we can write 2 to the power of n equal to 2. So that means 2 to the power of 2. Here 4 isomers are possible. 4. So this is 4 isomers are possible. And same, even cumulin is there. Even cumulin does not show geometrical isomers. So that means does not show geometrical isomers means there is no chiral carbon. So what it is there? Optically inactive. So optically inactive means here what it is? There is no chiral carbon. N equal to 0. So that means what it is? Number of isomers 2 to the power of 0. It is 0 only. What it is? Number of stereoisomers is 0. So which is 0? This is 0 here. Actually 0 directly. I just mentioned that number, right? Okay, now next one, even cumulin does not show geometrical isomers. Yes, repeatedly I'm saying that means how much important that concept. Easily can identify. In this, how many chiral center it is there? Only one chiral center it is there. Even cumulin does not show GI, right? So that means here n equal to 1. So 2 to the power of 1. So here common unsymmetrical formula only. No, unsymmetrical isomers, how do we identify? 2 to the power of n only. So 2 to the power of 1. So that is 2 isomers, cis and trans only. It is possible. Okay, so which is remaining 2 only. So this is 2. Hope you got the clarity. How do we identify and what is the main concept you have learned in this point? Come on, let's go to the next question. Column 1, it tells about the compounds, that is molecule, and compound 2, it is property. What are the property in that compound can be identified? Okay, so first and foremost, this is chiral or achiral. That is the first point. And whether it is POS, EOS is present or not, that is another point. And meso, it is possible. Yes. So these are the main points we are going to consider. Okay, in this compound 100% achiral, it is not possible because it is like somewhat unsymmetrical. So 100% it is a chiral compound. So chiral compound means how many chiral centers are possible? Come on, let us identify. And this is one chiral carbon. This is chiral carbon means what it is? 4 different groups or atoms attached to that carbon. That is called chiral carbon. So this is 1 chiral carbon. 4 different groups are available. So 1, and this is 2, and this is 3, and this is 4, 5, 6. So chiral carbon, it is 6 chiral carbons are there, and this is actually what it is. POS, COS will be absent. So POS, COS will be absent, right? So it is not similar, it is totally different, unique. Like, so this is actually chiral carbon 6 it is there, and POS, COS is absent. So POS, COS absent means what it is? Optically active. Yes, optically active. And the next one, what are the points to be noted down here? Optically active compound. And the next one, what it is? Compounds having even number of chiral centers. Even number of chiral centers, 6 it is there. 6 it is even, right? Of course. Right, now next one, here the compound, this also somewhat it is peculiar, somewhere it is unorganized, right? Okay, come on, here that is benzene, which is connected with wedge form. Here one. So how many chiral center it is available? Here one chiral center it is there, and at this point one chiral center it is there. So before me, I think you will be very fast to identify the chiral center, because it is very easy to identify, of course. Right, now here one chiral center it is there, here one chiral. What is chiral? 4 different groups or atoms attached that carbon, so that is called chiral carbon. So this is 1 2 3 4 5. So chiral carbon, it is 5. So now itself you say, ma'am, this is odd number. Yes, of course it is an odd number chiral carbon. So chiral carbon, it is 5. And next one, another one more point, what it is? Compound having odd number of chiral carbon, optically active. So this is no need to tell, it is optically active. So optically active, which is chiral carbon, it is there. So optically active. And next one here, CD. Yes, got it. Now third one, here ABC. So in this point, how many chiral carbon it is there? So this is also somewhat unorganized here. 1, and here what it is? 2, this point it is 2, and this point it is 3, and this point it is 4. Very easy, right? So exercise 2, it's really, I feel it is very easy. And the next one here, actually this point it is double bond, right? It is a resonance takes place, so it will not be a chiral center. So how many chiral carbon it is there? Chiral carbon, it is 4 only. So 1 2 3 4. No, 1 2 3 4. So that means which is the answer will be coming? Compounds having even number of chiral center it is there. So this is 4. And the last one, it is very easy. COOH, it's a meso compound, because same group which is attached to carbon. Meso, it is what it is? Minimum 2 chiral center it has to be present, but it will be identical groups which is attached. So this is meso compound P, right? Hope you got the clarity about what it is chiral, what it is meso. Meso compound, there will be a chiral center, but it will be equalized. So POS, COS will be present. So POS, COS is there, but whereas here POS, COS will be absent. So this is this point which we can say achiral. Achiral. So achiral means it cannot rotate PPL. I hope you got the clarity. What about that meso compound? What about that chiral compound? Hope you got the clarity. Yes. Come on, let's go to the next question. So column 1, they have given what it is compound. Column 2, it is actually molecule. What is that property? And the number of chiral center. That is what, as we have mentioned the previous question and last question. Yes. Now in that, how many chiral centers are possible? So here actually CH3, CH double bond, CH, CHD, CLD, deuterium. So that means carbon which is connected with 4 different groups or atoms. So that means here what it is? Carbon which is connected with what it is here? 1 carbon, 1 hydrogen, 1 deuterium, that is hydrogen's isotope, and 1 Cl. Yes, of course, 4 different groups or atoms attached to carbon. That is, this is also right different. Right, now CH. Okay, CHD, Cl. So this is 1 chiral center. So here, how many chiral center it is there? Only 1 chiral center it is there. So chiral center. So chiral center, it is 1 only. Right. So then you can ask this one. This one, it is actually which is connected with CH3, CH double bond, CH here. So this is 4 different groups which is attached. So in this POS, COS absent actually here completely. POS, COS is POS absent, COS also absent. So POS, COS absent means optically active, 100% optically active. And here in this point, plane of symmetry, it is available. There is no POS. POS, when you cut, it will be equal, right? So you cannot identify POS, COS. Both are different, right? Okay. Now next point. So here 1 chiral center it is there. Here 1 chiral center it is there. When you cut in between, so it is like equal. When you cut that apple, it will be equal, right? So this is when you are cutting, it will be equal. So that means POS is present. POS is present. So POS is present means it's a achiral. Second point, it is what it is? Achiral. Achiral. Second one, it is achiral. POS is present. And POS is present means what it is? Here, meso. This is 100% meso. Second one, it is meso. So meso, how many chiral center it is available? 2 chiral center. Yes, this is wedge side. Both are 2 chiral center it is there. So this is actually 2 chiral center it is there. 2 chiral center. Chiral center, it is 2. Right, here this is chiral center, only 1. Right, now third one, here CH3, N, ethyl group, O minus, N positive, O negative, HCl negative. See how nicely they have given. We can go for that. This is what it is. Lone pair of electron is there, no, like that we can. No, actually here they have given positive charge. That means this is 100% chiral. So chiral means what it is? Chiral carbon. How many chiral carbon? Only 1 chiral carbon. It is chiral center. It is available. Okay, that means POS, COS is absent, right? So chiral center is there means what it is. Here in this point, there is no POS, COS. Both all are different groups or atoms, right? So that means here what it is, optically active. So optically active POS, COS will be absent. It's a chiral compound. Right now, the last one, as we observe, only cyclohexane, which is connected with wedge Cl, both the side dash HH. Now this side also same CH2, CH2. This side also same CH. So 100% when you cut that happy like that, it will be half of that. So that means here what it is, POS, COS is present. POS, COS is present. COS is present. So the POS, COS is present means A chiral. A chiral means, can we say it's a meso? Yes, of course, 100% meso. Okay, now how many chiral center it is available? Can we say it's a chiral center? No, zero chiral center. Chiral center will be zero, right? Okay, hope you got the clarity about all these points. How many chiral centers? What are the properties? Plane of symmetry it is available. So here plane of symmetry, center of symmetry. Here POS, COS is actually present. POS is also present. COS is also present. That's what it is. A chiral. I just mentioned all this. Hope you got the clarity. Come on, let's go to the next question. We have to identify whether it is a chiral or achiral. Achiral means meso is available or not, and optically active or optically inactive. Easily we can identify. So as we observe, it's a chiral center. Here one chiral center. Chiral center is available. First of all, there is a chiral carbon. It is there. Yes, of course. And first one, this is actually two chiral center. It is available. So chiral center, it is two. Here one, here one. And when we cut over here, yes, exactly, it is cutting like apple. So that means what it is? This is achiral. So this is actually achiral. Achiral means, can we say it is a meso? 100% it is a meso. This is meso. Meso means minimum two chiral carbon should be there. And A chiral. POS is present? Yes, POS is present. So these are all the points are applicable for A. Now as we come to that B. So here one chiral center it is there. Here one chiral center it is there. Can we cut here? When we are cutting here, it will be easy. So that means chiral, first we can write chiral carbon. Chiral carbon it is 2. And POS is there. POS is absent. CO is there. COS is there. Yes, when you cut the crossway corner, center of symmetry it is there. Yes, COS is present, and this is a chiral carbon, chiral compound. So this is a chiral and this is a chiral, right? This is a chiral and this is a chiral. And the third one, as you observe here, this is actually as we are looking at the Newman's projection formula, just we observe this point, it is a front carbon, and this point it is a back carbon, right? So as we are observing, here one hydrogen, here one hydrogen, POS and COS. So POS, when we are turning this side, actually it is opposite side, no? So this is optically active. POS, COS will be absent. So POS, COS absent. So POS, COS absent means this is chiral. So it's a chiral means it is optically active. I hope you got the clarity. Okay, now next one. So this is actually D, right? So here C double bond C, here hydrogen, here hydrogen, here hydrogen, here. Even cumulene, this is 100% even cumulene. Even cumulene means what it is? It does not show GI, that you know very well. Right now here, this is actually achiral. Achiral. How do we say it's a achiral? Both are same group. So this is achiral. And the next one, E. So that means this is also even cumulene. And here, even cumulene. See, this is even cumulene. And the POS. POS is present or not? Yes, POS is present. So it's a achiral. Achiral, and the POS is present. And what it is? Plane of symmetry. Plane of symmetry. POS is present. Yes, of course. And the next one here, CH3, CH double bond CH, CH3. So in that, what do we observe? It's a molecular planar. See, it's actually a molecular planar like this. Right. Okay. So this is a molecular planar. Right. Okay. So that means here POS. POS actually, when you cut here, POS is present. So this is achiral. So I just write all these things, then we can finalize that, which is chiral, which is achiral. Now, the last one here, G, point G. So here, as we observe Newman's projection, see the top side, bromine and the dash hydrogen CH3 upward. So as we observe here CH3 and here CH3. So that means it's a cross, center of symmetry, it is possible. COS is there. So COS is there. And then, of course, 100%, this is what it is. Achiral. Achiral. Chiral, and it is meso. This is meso, right? Minimum two chiral center it is there for meso. And the last one here, how many chiral center it is available? 1, 2, 3. 3 chiral center it is there. So this is actually chiral compound. And the next one, this is wedge OH, this side also wedge OH, and this is what it is, OH, this is dash OH, this is also dash OH, this is wedge OH, CH3. So POS, COS, POS, COS absent. That's what chiral I just mentioned. Okay, now I hope you got the clarity. Now come on, let us find out here. Two of which are chiral and contain chiral center. So two are chiral, which are chiral center. So this is chiral and chiral center. So this is actually B and H. So this is B and H, it is chiral center. So this is B and H. And the next one, A chiral. A chiral, it is A, and the next one, G. See, A and G. Right, A chiral, right? So A and G. Right, third one, what it is? Here in the third one, here C. See what it is. See what they are mentioning, which two of which are chiral and does not contain chiral carbon, chiral center. So that is actually what it is. C and E, C and E. See, C. There is no chiral center. When you turn this side, no, there is no chiral. And next one, what it is? E, where it is E. So here also there is no chiral because even to me, there is no chiral center. And the last one, two of which are achiral and does not contain chiral center. So that means D and F, D and F. So which is D and F. D and F. Here also there is no chiral center and does not have chiral center. And achiral, this is achiral, no, D and F. This is chiral center. A chiral. This is a chiral. A chiral. Right. Hope you got the clarity about all these points. As we observe this only, we are getting that idea. Here they are asking, just we are bringing the point and we are merging. Right. Hope. Yeah. Come on. Let's go to the next question. Interesting. As we observe, cyclohexane, wedge, Cl, and wedge and dash also it's available. Okay. So in that two main questions, we have to analyze what are those two main questions. Which of the compound are optically active? Which of that isomer is more stable? That means most stable they're asking. Okay. Now as we observe one by one, we can come to know that idea about these two. Right now, first one, as we observe, this is 100% POS is present. So POS is present. So POS is present means achiral, achiral. Okay, so this is optically inactive. So that first point, it is optically inactive. Okay, I'll change the color so that it will be easy. Now next one, what it is here, as we cut over here, when we cut over here, both the side it will be equal, right? This side equal. So that means here also POS. COS also, POS is present, 100% POS is present. This is achiral, achiral. So achiral means what it is? Optically inactive, right? So second one also achiral, first one also achiral, optically inactive, and the third one also, see here when we cut over here, so when you cut over here also Cl it is there, here also Cl it is there. So that means what it is? This is also POS is present. So POS present means achiral. So achiral, so optically inactive. Right now, fourth one. So in that wedge and dash, half of that wedge and half of the dash. So this side dash and this side. This also POS is present. So achiral, right? Chiral, right? Okay, now that means optically inactive. Right now, the last one, yeah, previous one. So here, actually, when we cut over here, the side wedge, the side dash. When we cut over here, of course, this side it is wedge and dash, but of course, opposite side. That means this is POS, COS absent. At least one it is absent. So this is a chiral, right? 100% it's a chiral and optically active. At least one you are getting optically active, right? Now the last one. So as we observe here, dash, 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 dash. Here only two, it's wedge. So here POS 100% absent. So POS absent means here can you identify it is a achiral when you cut over here? Yes, you can get that Cl. Actually, it is a POS is present. Here, POS is present. It's a achiral. Why I'm mentioning here achiral? See, when you cut over here, see, observe clearly. So this you are getting what it is, Cl. So that means it is POS is present, achiral, right? Okay, now that achiral means optically inactive, right? So, okay, now in this point, what the question they are asking? Which of the compound is optically active? P, Q, S, and T. P, Q, S and T. So optically active, it is T only one. That is what I just mentioned. Only one compound it is got optically active. You'll be happy for it. So this is T only. And the next question, which of the isomer is most stable? This is actually one of the main important point to be noted. So in that we, as it has mentioned, it is a cyclohexane. We go for that what it is chair conformation, so that easily we can identify chair conformation most stable generally. Right now here in this point. So in this, here axial and equatorial we can identify. So this point axial and this point equatorial. Here down part only, no, this is up and this is down. So down part it is equatorial, right? I just mentioned here equatorial. And the same way here up and down. So this point it is equatorial. So one it is down, right? I just mentioned one it is down and one it is up. Just alternative it will be coming down up. And the third one here in this point you will observe here, this point it is equatorial. So equatorial means it is down, right? So this is down, up, down. And the next one here upwards equatorial. This point it is equatorial upwards. And the same way here what it is, this point up means this point down. This is axial and this is equatorial, right? And the same way this is up and this is down equatorial, right? So this down, no, this is up equatorial. So here down, up, down, up, down. This is down and this is up. So it is like alternative. As we are observing, this is down, up, down, up, down, up. So it is like a alternative way we are identifying to identify what it is most stable conformer. So as we observe all these compound which is having wedge and dash alternatively, in that way we can identify. Of course, compound R shows dash wedge dash wedge dash wedge. So 100% it is an alternative. Now I would like to give one more point over here to identify wedge. Here wedge, wedge upwards. Usually wedge it is upwards. Dash, dash it is downwards. Okay, now how to identify upwards if it is equatorial, right? Wedge upwards when it comes to equatorial. Down, that means dash downwards, it is equatorial. Wedge upwards comes means that is equatorial. Wedge upwards. So now you see wedge upwards. Where and all up it is available. So this is up and this is up and this is up. Wedge upwards, it is equatorial. And dash downwards. See, this is down, this is down, and this is down. Dash downwards, it is equatorial. Yes, I hope you got that clarity. Now, whichever it is alternative, as I mentioned, wedge dash wedge dash wedge dash. So in that way, equatorial position it is most stable 100%. So this what it is dialogue, you please remember wedge upwards equatorial, dash downwards equatorial. As we observe here in this chart confirmation, you don't forget upwards. Here downwards equatorial, upwards equatorial, downwards equatorial, upwards equatorial, downwards equatorial, upwards equatorial. So which is the correct option? Option R, for which of the isomer is most stable. R isomer is most stable. Why? Because it is alternative. Easily we can identify wedge dash wedge dash. Here also alternative, down up down up down up. So in that way you please remember this dialogue and this point alternative. So easily you can identify. Hope you got the clarity. Come on, let's go to the next question. It's very interesting question. A, B, C, D molecule they have given. We have to identify enantiomers, diastereomers, constitutional isomers are identical. How many are there? That means what is the value? Enantiomers means value will be 1. Diastereo means value will be 2. Constitutional isomers means value will be 3. And identical means value will be 4. Okay. Now enantiomers. What do you mean by enantiomers? Non-superimposable mirror images. That means it has to be a chiral compound so that we can identify non-superimposable mirror images, enantiomers like RS configuration. Then second one, diastereomers. Diastereomers means one it is fixed, the other will be changing. So that means what it is? Diastereomers. Cis and trans will be there in that way. So constitutional isomers means constitution position of the functional group will be changing. So that is constitutional isomers. And the last one, identical. Identical means it is a meso superimposable mirror images. Right? Okay, come on. Let us identify each one. Okay, now in that first compound A, it has mentioned Newman's projection. We have to identify whether it is identical or enantiomers or diastereomers or constitutional isomers. Okay, in that Newman's projection, COOH, this is a front carbon, this is a back carbon. So that is COOH, COOH, here front carbon. So in this point, here what it has mentioned, OH, here Cl, right? And the same way, back carbon, what it has mentioned. So in this, downwards it is COOH, it is there, no? COOH, upwards, opposite side. Here OHH, OHH. And the same way, other one pair is there, no? So other one, the same way, front carbon, back carbon. So front carbon, what it is? COOH, COOH. Here what it is? OH, OH, and here Cl, and the same way back carbon. Here opposite, here COOH, and then this side H, here OH. Right. Okay. Now, as we observe here, RS configuration, easily we can identify. So, RS configuration, in this what it is? This is as we observe front and back, like what to say, absolute configuration. So, you will get here also S configuration, here also S configuration. According to the trick I have mentioned, so please remember those tricks. If you are not getting, please go through all my videos so that you will come to know each and every point I mentioned. So that will be easy for you. And next one, here what it is, this also R and this also R. When you go for CIP rule, according to the RS configuration, absolute configuration, one it is yes, the other one it is RR. So that means POS, COS will be absent. See, when you compare both things, POS, COS, one side it is COOH, the opposite side COH. One side OH just to the opposite. Here also OH and that side OH. Cl and here, yes, here the side H. Right, opposite side. Okay, hope you got the clarity. R and S. So that means 100% what it is. This is called enantiomers. Enantiomers. Enantiomers, chiral compound only can provide that enantiomers. Why? Because it is optically active. Enantiomers are optically active. So compound A, it is 1. The value answer will be 1 as they mentioned in that question. And the next one, as we observe this point here and this point, I just enlarge that so that it will be easy for you to answer. So in this point here. Yeah. So in this point, what they are mentioning here also we have to identify what it is, absolute configuration only. So Br, here Cl, here fluorine and hydrogen. Whom you will give that higher priority? Higher priority will go to Br only. So this point it is Br. So this point it is Br 1, and of course the second one whom you will give chlorine 2, and this is 3 and this is 4. But actually what it is, interchanges will be taking place. Why? Because wedge side it has to be hydrogen, right? So interchanges will be taking place. So interchanges taking place means 1, 2, 3, 4. So what is the answer you'll be getting here? 1, 2, 3, 4. No. So interchanges taking place means this is anticlockwise. Actually, yes, it has to be there. Interchanges taking place. So R is there. So this is R. And the same way this side, bromine 1 and chlorine 2 and this is fluorine 3 and this is for bed side only hydrogen it is coming. So that means which is the way you are getting. So that means here also it is what it is, clockwise or anti-clockwise. So here 1 2 3 4, so that means it is clockwise. So this is also R. So R and R, it is identical. So what is the answer you will be giving for this? This is 4. Identical means 4 only, is that no? So this is 4, this is 1 and the next one. See, as we observe, this side left side OH and this side right side it is OH. So this is as same only we will observe. So that means same means what it is, this both are same. It is identical 100%. This value will be 4. And this one they have given what it is, Newman's projection, the other one they have given. So easily we can identify fluorine CH3 and hydrogen, it's a front carbon, and back carbon CH3 H and fluorine. Yeah, okay, come on, let us check whether this also is the same or different. Okay, now this carbon fluorine which is attached with the dash CH3, it's attached with that wedge, and hydrogen, see the same way, this is front carbon, no, this is front carbon, this point it is front carbon. So CH3 it's a wedge, and the fluorine it is a dash, and of course hydrogen is there down just to the here. Now you observe that back carbon, you see, now in this fluorine it is wedge, so where it is fluorine, this point it is wedge, and CH3 it is a dash, and hydrogen, now you see actually both are similar only, right? See, both are similar only, wedge and dash here they mention, here it is front and back carbon they mention, this is back carbon and this is front carbon. So this is also same only. Now same means what it is, value will be 4. So what are the points you will be giving? First one enantiomers, second one identical, third one identical, fourth one also identical. So 3 4s are 12 plus 1 13. So 13 value will be 13. See, here they are asking about that only, no, what is the value, A plus B plus C plus D. So A only is what it is, enantiomer, rest of that and all here identical. So you know what do you mean by identical, it is like A chiral. So the value will be 13, right? Hope you got the clarity. How do we identify? Mainly they are asking about this question, what it is, RS configuration and Newman's projection, how do we identify, right? Come on, let's go to the next question. What looking something different, but it is so easy. We have to identify the name of the compound. They have given a different structural way, but we have to identify the name of the compound. That is what it has mentioned. In each of the following three questions, a hydrocarbon is named. That is 2-methyl butane, 2,3-dimethyl pentane, 1-ethyl, 1,3-dimethyl cyclohexane. So for each, select from among the 16 conformational structures, that A to P, all structures that represents a possible conformers of that compound, and write letters A through P corresponds to your selection in each answer box. Right now, as we observe here, what is the name of the compound among these three? Right. So here CH3, CH2H5, CH3. Okay, now we will numbering from here 1. So here numbering 1 and this is 2 and this is 3, 4 and 5 here. So 1, 2, 3, 4 and 5. So 2,3-dimethyl pentane. 5 carbons are available. So 5 carbons means 2,3-dimethyl pentane. So here B is that. So this is actually what it is, A. A is there answerable. And the second one here 1, 2, 3 and 4. 4 carbons are there. 4 carbons means butane. In that way also we can identify. So 1, this is what it is. Here we can identify here 1 and this is what it is 2. This is 2, 3 and 4. So that means here what it is, A what it is, A means here 2-methyl butane. 2-methyl, this is 2, right? This is 1 and this is 2. 2-methyl butane. So easily we can identify. So this answer will be B. Here we'll put it B. According to that, easily we can identify. Okay, now third one. Okay, now this is Newman's projection. So this is a front carbon, back carbon. So in that 1, this is 2 and this is 3, 4 and 5. So pentane. So pentane means 100% this only will be coming. So easily we can identify what it is. 2,3-dimethyl pentane. Above that nothing will be there. If it is coming, it's wrong, right? In that way we can go. So 2,3-dimethyl pentane. So C is that C option. And the next D. So in that D, what it is, here also you see CH3, CH2, here CH3, CH3. So 1, 2, 3, 4, 5. 5 carbons are available. So 5 carbons means this is pentane. So that means this is B. So that means here, which is that D will be coming. So there are so many, what it is, 2,3-dimethyl pentane it is coming. Okay, now next one. Here also you see CH3, the front carbon CH3, and back carbon CH3, CH2. So that means how many carbons are there? 1, 2, 3, and 4. That means here 4 means it's a butane, right? So 2-methyl butane. So that means this is A, right? So that means here E, right? Now next one here, methyl 1, 2, 3, 4, 5. So that means here 1, 2, 3 and 4, 5. So that means here what it is, here 2,3-dimethyl pentane. So that means it is B over here, and this point it is here F. Right. Now next one it is, let us check. It will not go wrong. Let us go for it in that way. Okay, now next one, this is G. So in that, here what it is, CH3, CH3, C2H5, CH3. So that means here 5 carbons are there. So in that 5 carbon, no, here one front carbon and back carbon. No, so this is 1, 2, 3 and 4, 5. So that means which are the options are there? Only two options we have seen. So that means here 1 ethyl, 1 3 dimethyl. So that means here what it is, 3 dimethyl pentane. See, 3 dimethyl pentane. So this will not be the correct option, which is not available in this option. Okay, now let us go to the next one. Here what it is, CH3. So how many carbons are there? Here itself we can check it. Here 1 and 2, 3. This is actually what it is, 3 4 5, right? So that means 2 3 dimethyl pentane. So 2 3 dimethyl pentane, it is a B, right? So 2 3 dimethyl, it's a B, and here H, then and there we can write, so that will be easy for us. So 2 3 dimethyl pentane, it is H. All right, you please check it, and it is correct only. All right, now next one, what it is, this is cyclohexane. They did not mention only here. See, cyclo is, it is there, cyclohexane, it is there, because we are not going for it right now. Here in this 1 ethyl, yeah, ethyl, it is there, 1 ethyl, 1 3 dimethyl, 1 3 dimethyl, directly we can go for it. See, these points are actually, it will be very easy to identify. So 1 ethyl, 1 3 dimethyl, cyclohexane, this is actually C. So C, option C. So in that, which is A, B, C, I, this is I, this is I. Right. Okay, now next one. See, slowly they are increasing the level. Okay, now next one. So this is actually cyclohexane. This is actually cyclohexane. This is ethyl, here one ethyl group, here one ethyl group. So actually one ethyl only here, one ethyl, 2 3 dimethyl hexane here itself. So that means this is not the option only, right? So now directly we can go for it. So in the cyclohexane, that is chair formation. So one ethyl, 2 3 dimethyl, 1 2 3, easily we can identify. One ethyl, 1 3 dimethyl, cyclohexane. So this is actually what it is, C, and here actually K. See, slowly they are increasing the level, right? So if you are confident, you are able to answer each. So this also, you see, 1 ethyl, 1 3 dimethyl, 1 ethyl, 1 3 dimethyl. Here 2 methyl it is there. So 1 2 3, no, this will not be the correct. So this option is not correct. See, this option, and this option is not there. Okay, so nothing to worry. Whichever it is there, we'll go for that for the answer. Okay, now next one, it is M, right? So in that M, here C2H5, CH3, yeah. So that means here 3 3 dimethyl. 3 3 dimethyl, 1 2 3 4 5 6 7. No, this will not be the correct option, which has not provided the name, so nothing to worry. And here also ethyl group, 1 ethyl, 1 3 dimethyl. So what is that option again? I will read. So 1 ethyl, 1 3 dimethyl. No, here the options they have given here, 1 ethyl, 2 2 dimethyl. No, this has not given. So this also it's wrong. And here also 1 ethyl, 1 2 3. So 2 3 3 dimethyl. No, this also they have not provided the name. And the next one here, 1 ethyl. Here let us check it. Here that means here 1 2. See, this is 1 and this is 2 and this is 3. This is 3 and this is 4. This is 4 now. This is 4. This point it is 4 and this is 5. This is 4 and this is 5. So 1 2 3 4 5. So 1 ethyl, this point it is 1 ethyl, 1 3 dimethyl, 1 3 dimethyl, this point it is 1 ethyl, 1 3 1 3 dimethyl, this point 1 3, this point also, this one point also, methyl group it is there, you see this point, this is 1 ethyl group, 1 ethyl, 1 3 dimethyl, what it is, cyclohexane. So 5 6, that is there, no, 1 2 3 4 5 and 6, right? So that means this is what it is, C option. So in that P, this is P, right? I hope you got that idea how to identify. And you see, as we observe so many questions, no, we'll get the confidence we are able to answer. It will not go in the wrong, I hope. You all understand these questions, and thank you for watching for these questions. We go and solve the problems, all WH questions, we should ask ourselves that whether we are able to solve. Yes, we should have confidence in ourselves. Yes, we are able, because you know all the concepts and the sequence, and you are able to analyze. So you just ask all WH questions, like what is it, what, who, where, when, how, why. So all these questions you will be answerable. Have confidence in you, and thank you for your great support. Thank you very much.